In the Netflix movie Don't Look Up, a comet carrying $140 trillion in resources, including minerals critical to technology, is on a collision course with Earth. In the movie, they consider if they should divert the comet to prevent planet-wide extinction, or if they should bring it to the surface to access its resources and promote job creation. On October 13th, 2023, science fiction became science reality as NASA launched a mission to a metallic asteroid worth an estimated quadrillion dollars. The fall of 2023 is an exciting time for NASA and those that are interested in asteroids. The 7-year NASA OSIRIS-Rex mission to the asteroid Bennu concluded in September of 2023 when a capsule of asteroid samples landed in the Utah desert. Scientists estimate that they retrieved approximately 8.8 ounces of rock that could be studied for years to come. Now, initial analysis showed that these samples include a variety of materials, including pebbles, loose dust, and rock debris, and it seems to include or have the composition of carbon and water. Now, previously, the only asteroid samples from outer space that were collected by Japanese spacecraft. The first samples were returned in 2005 from the asteroid Itokawa and in 2021 from the asteroid Ryuguga. Now, in those cases, these samples were less than an ounce, so much less than the OSIRIS-Rex mission returned, and the materials that they returned were the consistency of a fine-grained sand. Now, the goal is that scientists will be able to study these samples and compare the samples in order to be able to better understand the composition of celestial objects, and it may provide very valuable information about the formation of Earth. In this great graphic from Science Notes, we can take a look at the different small objects flying through space within our solar system. So we started out talking about asteroids. And so an asteroid is an object that serves as a rocky body that is orbiting the star. And it could be a dwarf planet, it could be a remnant of an old planet, or it could even be the core of a dead comet. In contrast, a comet over here, they may still have a rocky or dusty core, but they've got lots of ice surrounding that core. And as it moves through space, the ice warms and releases gases, resulting in the tail of the comet. Now, what we can also see beyond the asteroids and the comets are things called meteoroids. Meteoroids are going to be much smaller, rocky fragments of these celestial bodies, such as asteroids and comets. Now, when it gets interesting is when these celestial objects, these small objects within space, come closer to Earth and actually interact with our atmosphere. And so if you've seen a shooting star or you've seen a meteor, what you've got are these meteoroids that are coming into the atmosphere, and as they move through the atmosphere, they're going to heat up and basically kind of burn up part of the composition of the structure, and you see it appearing again as a shooting star. And then ultimately, for many of these meteors, as they're coming through the atmosphere, they're going to be burned up before they hit the ground. But if they hit the ground, they're going to be referred to as meteorites. And so the meteorite then is a remnant of a meteoroid or an asteroid or a comet that has impacted the surface, and it can be studied. But the composition that makes up this meteorite may be damaged by coming into the atmosphere. And so it's been heated up, so it potentially burns the materials. It's interacting with oxygen in the atmosphere, which could contaminate some of the materials that are within it. So if we look spaceward, what we can see is there are asteroids in the solar system that are so dense that they are heavier than the naturally occurring super heavy elements on Earth. And so for scientists, this is really interesting. There are theoretical elements that are highly radioactive and break down quickly that may be found in space that can't be found on Earth. And there may be other stable elements, so elements that are not breaking down as quickly, that may have properties that are impossible to predict because we can't find them and we can't study them on Earth. But they may be present in some of these asteroids. Now, what makes these asteroids of particular interest is the fact that they contain metals that are needed for our emerging technologies. And so things that are used in our smartphones, things that are used in clean energy for like solar panels or for windmill turbines, batteries for electric vehicles, all kinds of things like that. In our technology, we need these precious materials. Now, currently, the only source for these precious materials is mining them from the Earth. And so the two most common ways of obtaining materials from the Earth are through either surface mining, sometimes referred to as strip mining, or underground mining. And so surface mining or strip mining is when basically you open up this large pit area and dig out that pit, making it ever larger and ever deeper in order to collect those materials. And it could have a huge environmental impact on the surrounding region. Underground mining, is illustrated over here on the right, has much less of an environmental impact, but it tends to be much, much more expensive than strip mining. Now, in both of these cases, surface mining and underground mining can produce harmful byproducts involved with the processing of the crude ore in order to extract and purify the desired materials. Now, in addition to that ecological impact of mining for these rare earth minerals, there are also significant concerns about human rights abuses and exploitation of workers and their communities. So if we look back at the asteroid Psyche, the asteroid that NASA has launched a mission to in October, what we can see is that scientists estimate that Psyche has enough gold to make every person on the Earth a billionaire. Or it could collapse the gold market and disrupt the global economy. Now, previously, the cost of launching a satellite or launching a mission to an asteroid to return resources for uses like clean technology or for our smartphones was not necessarily economical to collect the resources in this way. Several space companies that were formed when asteroid ownership was made legal in 2015 have stopped their efforts to mine in space because at that time it was impractical. Now, however, as we're seeing with the use of reusable rockets, the cost of mission launches or rocket launches is continually to come down. And therefore, other companies are now preparing to test their technologies in space as the demand for rare materials and rare metals for electronics and clean energy and electric car components continue to rise. It may be economical to start to mine these resources from outer space. Now, the news that the Psyche asteroid may have enough gold to make everybody on Earth a billionaire may not be fully true. There are other economists that put a damper on this news because they say that the economical impact of bringing these valuable resources to the Earth is much more complicated. But at a minimum, mining resources and bringing them back has the potential to make those that are obtaining those materials much, much richer. So for this week's Ethical Dilemma in Science, I'm broadening it up a little bit from just looking at NASA and the mission to Psyche and ask the question, should we mine asteroids for these precious materials? Who has the right to mine space objects? And do the products of space mining belong to all of humanity or only to the entities that can reach and extract resources from them? How can the benefits of space mining be distributed fairly, especially to ensure they benefit all of humanity and not just a select few? And then finally, could competition over asteroid resources spark global tensions or conflict? Thank you for listening to this week's Ethical Dilemma in Science. As always, please see the description below for additional information and references. Thank you and have a great week.